Ready, guys? Okay. So again, read this problem and then look at how the system matches it. Again, I might not give you that system in the future, so you should be able to come up with this, because if you let y equal t, which is your age, okay, we use t for time, then your cousin's age, y, would be yours, which is t plus 3 more. Does that make sense?
Yep.
Okay, now obviously those are linear equations, which we can graph by using m and b. So you should all agree that b is what? What's b there? What's b?
3.
Careful. 0. What's m? 1, which you can write as 1 over 1. So if you graph that equation, you would start the line at y equals 0, and then go up 1, right 1, up 1, right 1. Do it several times for me. Okay, and then connect them with a line. Okay, and then okay, shh, guys, quickly, quietly, just grab a ruler. Okay, shh. So, Felipe, what is your y-intercept on this one? Y equals t plus 3. Felipe, your y-intercept b is what?
0.
That's kind of like y equals x plus 3. So what is it? What is it? B is 3. Okay, what's your slope there? 1. Yep, which you can write as 1 over 1. So this line starts with a y-intercept of 3, and then you go up 1, right 1, right? For the change in y and the change in x, right? Okay, so yeah, so it looks like these lines are parallel, and we know parallel lines what? Never intersect. So notice, how far apart are these lines always? They're all what? They're always what? How far apart? 3 units apart? Okay, so that's the vertical distance, and that represents your what? Your difference in the what? In your what? Age. Okay, so do they intersect? No. We already said no, right? And what does that mean in this problem? Remember, y is age, right? Y equals t is your age. Y equals t plus 3 is your cousin's age. So you guys, what does this mean then, that they never intersect? That means, right, so you'll never be the same age, right? You'll never be the same age. Isn't that what that means? The fact that these lines are parallel? Okay, now we're going to solve it again, this time using substitution. So here we go. All right, Robbie, Kay, what substitution would make the most sense here? Right, but I'm saying, what are you going to substitute in where? Since y equals t, you're going to put that t where? Yeah, in place of this y. Everybody agree that's the substitution that makes the most sense? So doing that, I get what? T equals t plus 3? Everybody agree when I make the substitution, right? I get that? And then you want to get the t's together, and how do I do that? Chloe, what do I do to both sides to get those t's on the same side? Okay, subtract t, good. Now watch what happens, guys. What happens is the t somehow gets eliminated. Well, if the t gets eliminated and you end up with something like this, which is never true, is 0 ever equal to 3? Wait, what does that tell us about the system? So the system has what? No solutions. Very good. So if it has no solutions, what does that tell you again about your age and your cousin's age? Again, they'll what? Never what? Never be the same. Okay, so you guys, again, take a look at this, because this is half of what we're learning today. Don't turn the page yet. Quickly review. Okay, so we came up with the system, which graphically we saw had no solutions because the lines are parallel. And then using substitution, we saw it had no solutions because we ran into a statement that's never true with the variable being eliminated, right?
Right.
So these are the same system. We're just solving it two different ways. Okay, that's half of what you're learning today. Do you get it?
I got it.
Okay, here's what else we're going to learn. Shh, problem 2. Shh.
I get it.
Okay. All right, again, you guys, today I'm giving you these equations, but on the test you might have to come up with the equations on your own. So I want you to pay attention to what I'm doing and where I'm getting these equations from. Okay, here's a number puzzle. Ready? Suppose x and y are two numbers. And here are your two clues. Clue number 1. Y is 5 more than twice x. What? Oh, I'm sorry. Y is 4 more than twice the value of x. By the way, the word is, you're going to replace with what? Equals. Okay? So when you're turning it to a word problem, the word is, in this case, is definitely an equal sign. So you write y is, in other words, y equals what? How do you get 4 more than twice x? 2x plus 4, right? Or you can write 4 plus 2x, same thing, right? What's your question? It says y is, so I wrote y equals 4 more than, in other words, to get 4 more than a number, don't you add 4 to it? And what's it 4 more than? Twice x, in other words, 2 times x. 4 more than twice x. Got it? So twice x is 2 times x. Okay? Okay. All right, let's look at clue 2. The difference of 3y and 6x. How do you get the difference between two things? You what? You what? Subtract them. And what does that equal? It equals what? Yeah, well, it equals 12, right? So you get the second equation. So there's your system. Everybody agree that's my system for this puzzle? Okay? System is just 2 equations. Right? A system is 2 equations or more. No big deal. Okay? We're not doing products of a system. This is just a system. A system of equations is just 2 equations. What's that? What's wrong? I didn't do anything yet. All I did is roll 2 equations for the 2 clues. That's it. That's all I've done. I haven't done anything else. Okay. All right. Now, we want to graph both equations in the system and find the solution that way, just like you did back in section 4.1, right? Is that clear? Okay, so here we go. Notice how this first equation is in slope-intercept form. So I'm just going to use what? Yeah, b and m. The second equation is in standard form. And even though you could change it to slope-intercept form and use m and b, I'm not going to do it that way. The easier way would be what? To find the intercepts. That's the easiest way to graph an equation in standard form. But it's up to you. If you wanted, you could change it to slope-intercept form and then use m and b. Either way. All right, so here we go. Let's take the first equation. And again, since it's in slope-intercept form, I'm just going to use my b and my m to graph the line. Ready? Okay, so b is 4. 1, 2, 3, 4. Everybody do this. Then you're going to go up 2, right 1, right? Or I could go down 2, left 1. Same thing, right? Okay, now the second line, which is in standard form, I'm going to graph a different way. The quickest way to graph that is to just find the intercepts, right? So put in 0 for x and find y, and then put in 0 for y and find x. Are you following me, guys? Do you remember that?
Yep, I'm following you.
Okay, so if I put in a 0 for x, I get that, which if I divide by 3, I get what, guys? I get what? 4. Okay? So 1 point on my line is 0, 4, and then I'm going to put in 0 for y, right? And solve for x. Now be careful on that. 3 times 0 is 0. 0 minus 6x gives me negative 6x, and then divide by negative 6. And I get x equals what, guys? Negative 2. Okay, so when y is 0, I figured out that x is negative 2. So remember, what this does for us is just gives us 2 points on my line, right? Isn't that all I need to draw a line is 2 points?
Yeah, it does.
Okay, so that's what I'm going to do, right? I'm going to plot those 2 points to graph that second line. So here we go. 0, 4 is there. Negative 2, 0 is there. So guess what, guys? The red line is right on top of the green line, isn't it?
It is.
They're the same line, aren't they?
That's crazy.
They're the same line,
Whoa.
aren't they?
Yeah. Perfect, man.
Okay, so do they intersect?
No.
Yeah, they do.
Yeah.
They intersect everywhere on the line, right? Shh. At all points on the line.
Yep.
Every point on the line is where they cross, right? So at every point on the line they intersect. Okay? So I want you to pick any point on the line.
Let's do 0, 4.
Well, pick a different one than the ones we already worked with.
Oh, let's do
Negative 1, 2. All right.
fine.
Shh, doesn't matter. Shh. So just pick any point like negative 1, 2. Doesn't matter. Okay, so here we go. So put y there and put my x there and see if it works. Tell me, is that a yes or a no? Does that work? Let's see. I get negative 2 plus 4, which is 2. Do I get 2 equals 2? It works, doesn't it? Okay, try it over here. So replace my y with 2, replace my x with negative 1, which gives me 6, plus 6, which is 12. And I get 12 equals 12. You see how it works? It makes both equations true.
I see it.
Okay? So, do you think every point on the line will satisfy both equations? What does I mean by satisfy? Make it what? True. Okay, do you think every point on the line will make both equations true? Yes or no? Every point on the line, what do you think? Yes. That's what we said earlier, didn't we?
Yeah, we did.
They're the same line, so they better make both equations true, right?
Yeah, okay.
Got it?
Got it.
Okay, so in conclusion then, how many solutions does the puzzle and the system have? Infinitely many. Why?
Because
All intersect the same line.
Yeah, aren't there an infinite number of points on a line?
yeah, there are.
And so if the lines cross at every point on the line, there's going to be infinitely many solutions.
Yeah.
Okay? Any questions so far? Any questions? All right.
No questions.
What's that? All this is going to be on the test, absolutely. Okay, so now we're going to solve it again, this time using what method? Substitution. Okay, so here's my system. Let me recopy it again. Here it is. Okay, what substitution makes the most sense here, guys? If you did your homework last time, this should be an easy question. What substitution makes the most sense there to solve the system by substitution? Plug in what, where?
Plug in the top one and go to 3y.
Okay, so in the first equation, since y equals all of that, I can take all that and substitute in for that y, can't I? Okay, so that's what I'm going to do. Watch what happens, guys.
6x plus 12.
Hold on. Shh. So I got 3y minus 6x equals 12, and I'm going to replace the y with what? 2x plus 4. All right, now clearly I have to distribute that 3, don't I? Okay, so I get 6x plus 12. Okay, any questions so far? Now those x's are on the same side, so should I combine them? What do those combine into? 0. Don't they cancel out? Okay, now this time x canceled out, but I ended up with a statement like that, which is always true, isn't it? Isn't 12 always equal to 12? And so what does that tell you about the system? So the system has what? Yep. Infinitely many what? Solutions. Okay, so remember that. So the system has infinitely, I'm abbreviating infinitely, by the way. Okay, so I'm just saying that the system has infinitely many solutions, right?
Right.
Okay, so this is what the two things we're doing today. We're talking about what? Let's hold on. Let's back up and summarize what we did. On problem 1, the lines were parallel, and we ended up with something like this, right? With the variable getting eliminated and it never being true. Here they were the same line, right? And when we solved it by substitution, we ended up with something like this, right? With the variable getting eliminated, but you ended up with a statement that's always true. Do you see how those go hand in hand? Okay, so basically then, this is a conclusion then. All right, Mark, can you read the first box? Real loud.
The system of equations in intro problem number 1 has no solutions. Write this type of system.
No, with this type of system.
With this type of system, discuss the following. 1.
Go ahead.
The graphs of the equation are lines with the same slope but different y-intercepts, which results in parallel lines that never intersect. 2. When a previously learned method of substitution or elimination is used to solve the system, the variables will be eliminated and you will end up with a statement that is never true.
Okay, so doesn't this first box cover what we learned in that first problem in the activity? Okay, Jacob, you can read the second box real loud.
The system of equation in intro problem number 2 had infinite solutions. With this type of system, you solve the following. The graphs of the equations are
Yeah.
lines with the same slope and the same y-intercepts, which results in identical lines. So every point on the line.
Okay. Read that.
When a previously learned method, substitution or elimination, is used to solve a system, variables will be eliminated and you will end up with the statement that is always true.
Okay, so isn't this what happened in the second intro problem? Again, so those are the two things that we're going to be running into today on all the examples. So, here we go. All right, so Tyler, I don't know why I called you Troy. Tyler, go ahead. Example 1. Read it. Yep.
Decide which method, substitution or elimination, would be easier to use to solve a system of equations, then solve it and answer the questions below.
Okay, so look at that. What do you think, Tyler? What method would be easier to solve that system? Elimination or substitution? Definitely elimination. So, guys, what should I do to set up the elimination here?
Times the top equation by 2.
Multiply the...
Negative 2.
Okay, everybody agree? Shh. I should multiply the first equation by -2 to set up my elimination? Yes or no?
Yes.
Okay, I want everybody to do it. And I want you to rewrite it here. So my new equation 1 becomes this. Whoops, that's an X, right? Sorry about that. And I'm leaving the second equation alone. Did everybody catch that?
Yeah, I got it.
So all I did was multiply the first equation by -2, and then I rewrote it as -8x minus 4y equals -10. Everybody agree that's what I get?
Agreed.
Okay, now you add them together, right? And what happens when I add them together, guys, straight down? The x's cancel, but also the y's cancel, giving you 0 on the left side, and what do I get on the right side? -7. Is 0 ever equal to -7? No, never true.
No solution.
So therefore, the system has what then? No solutions. Right? Makes sense? And since there are none, I don't have to describe them. Now, question for you. What if we had used the graphing method instead? What would we have seen? You don't actually have to graph, but what would you have seen? Predict what you would have seen. Well, not on the calculator, just on graph paper. What would you see? Yeah, you'd see 2 parallel lines, wouldn't you? Wouldn't you guys?
Yeah, we would.
Isn't that the type of system graphically that has no solutions? Right? Everybody understand? Okay or not?
Okay or not?
Okay. Well, or not.
Okay.
Okay. All right, next page. What? I'm going to write your cooperation grade on the right page. What, you were on example 3 or something? Okay. All right. All right. Well, Jason, you can help me here. Look at that system. What method would be easiest to solve that system? Substitution or elimination? Substitution. So what are you going to do? You're going to replace x with what? Okay. So everybody agree you could take that y plus 8 and put it in right there? Okay, so let's do that. So I'm going to take the second equation, and I'm going to replace the x with y plus 8, right? And obviously, I'm going to have to distribute that negative 2 now, aren't I? Everybody agree you're going to have to distribute the negative 2? So go ahead and do that. And that gives me negative 2y minus 16 plus 2y equals negative 16. Okay? Any questions so far?
No questions so far.
Okay, when I combine these, when I go to combine those, I get what? 0. So they cancel out, and I end up with a statement that is what? Always true. So when you run into that with the variable being eliminated and a statement that's always true, you'd say what? It has how many solutions?
Infinite.
Infinitely many.
How many solutions are there?
You substitute it into the second equation. Then they become one equation, right? That's what happens when you substitute. What's wrong? Oh, yeah, there's a lot of solutions, exactly. Okay. Shh. Now, if there are any, describe them. Well, basically, what happens is they're the same line, aren't they?
Yeah.
And so you can say the solutions are all points on the line, right? Again, the equations form the same line. If you had graphed them, you'd get the same line. So any point on that line will be a solution to the system. Is that clear?
Clear.
Stay with me, Nathan. No leaning. No leaning. Okay. Shh. If you had graphed them, describe what you would have seen. Shh. Guys, if you had graphed these, what would you have seen? One line. It would have been the same line, right?
Yes. No. Two different lines.
Two lines that are on top of each other. So that which is the same line, right? Got it? Isn't that what you would see graphically if you had done it that way? All right, everybody try example 3. Go. Give it a shot. Everybody do 3. Like subtraction?
No, I don't.
Cooperation?
Oh.
You said
Nah,
math.
I need like 45 of those.
Oh, you like only positive math, huh?
No.
You like only addition and multiplication? You don't like subtraction and
So
division?
example 3. Yeah.
Okay, keep going. You done?
Do that.
Yeah, you can do it.
I'm gonna.
divided by 7, which would be a lot lower than 40. Yeah, it's going to be a slam dunk and you losing points.
Oh!
Right? Okay. Shh. Okay. You guys, what method are you going to use here? What do you think? Let's do elimination. Okay, so you would multiply the second equation by what? I don't want to ruin my system, so I'm going to recopy it before I do anything. Okay, so I'm going to multiply what by what to set up the elimination?
Bottom one by -2.
Everybody agreed? Multiply the bottom one by -2? Okay. And then I'm going to rewrite it. Giving me -2x plus 4y equals -20. And now I'm going to add them together straight down. Is that clear? What happens, guys? Yeah, the x's cancel, and you get 7y on the left side, and you get -21 on the right side, which you can finish by dividing by 7. And you get y equals -3. Well, once you find y, you should be able to find x by putting it into one of the original equations. Which one are you going to put it into?
First one.
Doesn't matter, but I think the second one's easier, right? Okay, guys, shh. Okay, so let me do this real quick. Everybody do it with me if you haven't done it already. Okay, doesn't that give me x plus 6 equals 10? And then I subtract 6 and I get x equals what? 4. Yeah, but it was minus a minus, which turns into a plus. Right? Okay. So, everybody agree that I have one solution? And it says to describe it. What is it? It's what? Yeah, what is it? Negative, or 4 comma? -3. Okay? And now, if you had graphed the system, what would it look like?
260 lines.
Yep, 2 lines intersecting at one point, right? And what would that one point be?
4, -3.
Yep, they'd be intersecting at the point 4, -3. Does everybody understand that? Okay? All right, so based on what you learned today, you should be able to do the next example all on your own. I'll give you about 4 minutes or so to do it. So work quickly. Talk about it in your groups, guys. Okay, so talk about it in your group. You should not be doing any graphing. You should not be doing any solving. All you should be able to do is look at it and use the M and V to predict what would happen if you did graph. You're not actually graphing, though. You're not actually graphing. And you're not actually solving either. Okay, so these are 2 lines. Describe them. Like would they be on top of each other? Would they be intersecting at one point? Parallel? Why? Is that the only thing you're using to make them on top of each other? You also have the same y-intercept, right? To be on top of each other. There's different y's, like one will be up here, one will be down here, right? They're 2 different b's. different E's. How are you going to do the same line with different B's? Different y-intercepts. They're going to cross at two different points on the y-axis. What? Same slope, different B's. Same slope, different B's. Guys, same slope, different B results in what type of graph? Parallel lines, right? Think about it. They cross at two different B's, right? But they lean the same way. Parallel lines for part one, right? Okay. Parallel lines, a system of parallel lines has how many solutions? Zero. Zero. Good. Now keep going. We've kind of touched on it today several times. Is that what you mean? Maybe a little bit. Not really. We had never really talked about systems until this chapter. Graph lines. Maybe last year you did a little bit. They have different B's, right? They have different angles. They're going to lead different across. Again, they have different slopes. They're going to cross one time. Right? They're either going to cross always the same one, or they're going to cross together with parallel. So they're going to cross once. Those are your only two choices, right? I mean, lines aren't going to come back and cross again, are they? No, they're going to be lines, right? You have two different slopes. You didn't show your work. I don't understand. You wrote different slopes. Different slopes do not result in parallel lines. That's the same line.
How would you do a description?
You got to do something first. What?
How would you do a description?
Again. Three different scenarios. Right? Either they're parallel, they cross once, or they're on top of each other. That's what I mean by description. Yeah, simplify it and answer the question. You guys, let me warn you. Be careful on C. Be very careful on C. I tried to trick you.
Why would you trick me?
I tried to trick you. Say that. Okay. Shh. Ready? Okay. Shh. Nathan. Shh. Give me the M and B for this first line. 2 and. Shh. Okay, guys. What about this line? Okay, guys, think about it. They have two different y-intercepts, so you're going to cross at two different points on the y-axis, and then they're going to lean the same way because they have the same slope. So this is going to be a system of parallel lines. Everybody agree? And since parallel lines never cross, the system will have how many solutions? None. That's fine. Guys. Okay. All right. Victoria, can you give me M and B for this one?
2/3 and 4.
Okay. What about this one?
1/3 and -4.
Okay. So you guys, I'll tell you right now. Anytime lines have different slopes, they're going to cross one time, always. Is that clear? So it really doesn't matter what the B's are. If the slopes are different in this case, they're going to cross somewhere one time, right? So you have lines crossing at one point, right? Everybody agree?
Agree.
And so if they cross at one point, how many solutions does the system have? One. All right, now be careful here. For that first line, what's M, everybody?
3.
What's B?
5.
5. Now wait a minute. The second equation is not in slope-intercept form. So you're not ready to pick out M and B yet. So you got to what?
Divide 4.
Divide by 4. to get it in slope-intercept form. And that gives you that. So M is 3 and B is 5. But your slopes were not right. Now they're right. Okay, so again, if they have the same M and the same B, they have to be the same line, aren't they? So to describe the graphs, it'd be the same line, wouldn't it? And how many times do the same lines intersect? Infinitely many times. So there are infinitely many solutions. Okay. All right, now, sure you want to miss this one? This one's going to be tricky.
Can I miss this one?
You can miss a cooperation point. All right. All right, Ryan, you can read the problem real loud.
Wait, which Ryan?
You.
Gift basket has 2 soaps and 5 lotions and costs $20. A second gift basket has 6 soaps and 15 lotions and costs $50. Is it possible to determine the price of the soap?
Okay. That's what we need to figure out using our knowledge of systems. Are you ready? What don't we know? What are our variables, in other words? The price of what? One soap and the price of one lotion. That's what we don't know, right? We're trying to kind of figure that out, right? So I'm going to let X equal the price of one lotion. And I'll let Y be the price of one soap. It doesn't matter which one is which, okay? As long as you let X be one of them and let Y be one, you'll be good. Okay. You know what? Let's change that. Let's make this soap. I just like to go in the order it's mentioned so I don't mix them up. It's not that it matters, but I'd rather go in the order that they're mentioned just to make it easier for me to set up the system. No, you're not. Okay. All right. Marissa, I'd like you to read that first sentence. Marissa B. And I'd like you to write one equation based on that sentence that I just circled. Okay, so what would be the equation if X is the price of one soap and we use Y for the price of one lotion? What would that equation be? Okay, 2X, yep. Uh-huh. Okay, good. Everybody see what she did? She took the price of one soap, which is X, and multiplied it by 2, because there are 2 of those, plus she added 5 lotions times the price of 1, which is Y, and altogether added up, it costs $20. Does that make sense?
Yeah, it does.
Okay. Shaylin, can you read the next sentence and write my second equation for my system? So what would be the equation if X is the price of one soap and Y is the price of one lotion?
6x plus 15y equals 6.
Okay, good. All right, guys, ready?
Ready.
You with me?
With you.
Please. Shh. You're going to cut your cooperation grade. You do that, okay? All right, now clearly I'm going to use elimination. You understand that by now, that this is one you want to use elimination on?
Yeah, it does.
Okay, so Keely, what would I multiply by and where to set up the elimination? Obviously, there's more than one right answer, but what would be the most obvious thing to set up the elimination?
You want to like multiply 2x plus y.
So multiply the first equation by what?
By -3.
Everybody agree? You multiply the first equation by -3 to set up the elimination?
Agreed.
I agree. Okay, good. All right, let's just rewrite it. So now my first equation is that minus that equals that, right? And leave the second equation alone. Just recopy it. Everybody understand? You're leaving the second equation alone? You're just recopying it, right? All right? Now, what happens, guys, when you add these two equations together, straight downward? What happens? Well, when you add them together, the x's add up to 0, the y's add up to 0, giving you 0 on the left side. And the right side, I get what? -10? Okay, so what happens when the variable gets eliminated and you end up with something like this that is never true?
No solution.
That's right. There's no solutions. So if there's no solutions, the answer is what? Well, answer the question. I can't figure it out, right? I can't find the price of what? Of one soap. Okay, so if the system I came up with doesn't give me a solution, then obviously I can't answer the question, can I? Do you agree you cannot answer the question there? Okay. All right, last page. Okay. Shh. Mark, read this really loud. Really loud.
When we solve a system of equations such as y equals 2x plus 1, y equals 1 plus x
A little bit louder.
Okay. Where both equations are in y equals form, we are essentially just setting the right sides equal to each other and then solving the resulting equations.
Okay, so basically, guys, if that's y, can't I just put that y in there, giving me that? I mean, basically, that's what you do, right? If you're going to do substitution, right? Okay, and so what I'm going to do is go backwards now. I'm going to take something that starts out like that and turn it into something like that. I'm going to go backwards. Are you ready?
Ready?
Okay, so doing that, to solve an equation like this, what I can do if I want is what? Graph y equals the left side, graph y equals the right side, and then what? Find out where they what? Find out where they intersect. And right? And so the x value will be the solution of the original equation. Does that make sense? Okay, so here we go. Here's an example. Suppose I want you to solve that not on paper, not by using algebra, but by graphing.
Okay.
So what would I do? I'd graph y equals the left side, and then graph y equals the right side, and then find out where they're equal. In other words, find out where they cross. Does that make sense?
Yes, sir.
Okay, so here we go. First line. Go ahead, Michael. What's M? Or B? What's B?
B would be 1.
M would be
M would be -2.
over 1, right? Okay, and then
Another 1,
B would be,
1,
and M would be
-1/3.
-1 over 3. Okay, so here we go. So the first line I'll do in red. So B is 1, and then I go down 2, right 1, right?
Yeah.
Do it again. Down 2, right 1. Okay, connect them. Okay, and then I'm going to grab the second line with a blue pen using M and B. So again, B is 1. And then I go down 1, right 3, right?
Right.
Okay, now, where do the lines cross? They cross at the point what? Wait a minute. Oh, I copied one wrong, guys. Yeah, it should be -4. Sorry, guys. All right, so let me fix that. Shh. Shh. Guys, let me fix it, okay? Shh. Cross that line out. Okay, so B is -4. 1, 2, 3, 4. Shh. Then I go down 1, right 3. Sorry about that, guys. I just copied it wrong. It's all I did. Shh. All right, so where do these cross? They cross at the point what? 3. No, 3, comma. Come on, guys. -1, 2, 3, -5, right? All right, now hold on a minute. Now hold on. I'm trying to find the solution to this equation, which only has x in it. So my solution is what? X equals what? Guys, what is it? What's my solution? 3. You only keep the x value from your solution point because your original equation that you're trying to solve only had x in it, didn't it? Does that make sense? Yes?
Yes.
Okay, so we're using the graphs to find the solutions to that equation, and there's one solution that's x equals 3, so you just ignore the -5 on this question. Is that clear? Okay, everybody do B. This time you're going to do it on the calculator. So come get a calculator. Do it, everybody.
You want? Yeah, sure.
Hey, Mark.
I found a free app
find the free app that's a cooperation grade calculator? Did you find that one, Mark? The cooperation grade app?
It tells me how good my cooperation is.
Or how bad it is.
Oh, I don't think that's enough.
Get a new one? It's the same one? Yeah, everybody do it same way, but instead of graphing on paper, I'm letting you graph it on the calculator. So it's actually easier, isn't it?
Well, like comma 8, don't let me do equals 8.
Where's yours? Come on, guys, you can't be lazy.
It won't let me do equals. You have to do it. Speak with no 80. Whoa, dude.
You're doing, no, you're not doing it on the home screen, you're doing it where? You gotta graph it, you gotta do it in one app. You're just cross, your screen's just not big enough, you have to change your window. Change your window.
I get it. Okay.
Second trace.
Oh, ooh, I got it. Oh, first curve now, right? Second curve? Yes. Sure. You should guess. Cool. I like guessing. Except on tests, 'cause that's bad.
You might have to change the window to see where they cross. You might have to change the window, think about what to change it to.
Get? Are we trying to find y, bro?
Okay?
12.878788.
You got the solution?
Bro. Oh, I'm going to put y equal to 8.
Originally, you know we have the x, right?
You must be. I'm pressing enter on second curve.
There must not be a second curve then if it's not finding one.
Yeah, just make that 13.
Okay, start by hitting zoom key.
Oh, good. 13. I want to make it 13. That's crazy.
Okay, and now you need more what?
An 8 grade. That's kind of
Well, wait. You're supposed to be, look what we did here. We grabbed two different equations. Is there a way to solve this equation? Since you have two different equations here.
That's it.
Right? Alright guys, here's what you need to do. It doesn't matter what the equation is. If I let you solve it by graphing on a calculator, all you got to do is graph y equals the left side and then y equals the right side and find out where these two graphs cross. Does that make sense? Okay, just like we did on part A, except this time we're going to graph it on the calculator instead of on graph paper. So here we go. Ready? Shh, guys, please have a seat.
Got you.
Okay, so that's what you're going to graph. Everybody agree? Yes or no? Okay, so you start with the standard window by hitting Zoom Z standard, right? And it looks like you're going to cross somewhere off to the right. So what am I going to have to change in my window? Yeah, I'm going to have to change my X max, aren't I, to something bigger to see it? Maybe make it 20, I don't know. If that's not big enough, you can change it again later. Anytime you change a window, you hit graph. Okay, I can see where they cross, and now you do what? Second, trace, intersect. First curve, just hit enter. Second curve, just hit enter. On guess, move close to where they cross and hit enter again. You're not done until it says the word intersection. No, so you guys, the solution is what? Remember, you don't want the y, you just want the x. So 12 point what? X is about 12.88, isn't it? Everybody agree? It's approximately 12.88. There it is. Okay, so which ones on your homework are you going to do like that? No. 9 and 10 on page 182. How are you going to do these two problems? By graphing on graph paper like we just did in part A. How are you going to do those? Shh. Just follow the book directions. How are you going to do this? By graphing on graph paper. How are you going to do these? Using what? Substitution or elimination. So follow the directions. You guys can take a 3-minute break, but at 12 minutes to, I want to see all your books open and you guys working quietly. What's up, Nathan?
Do you mind if I borrow a piece of graph paper or something?
No
similar?
problem.
You're still recording.